Oops. I forgot the microphone again. And it's dangled. Caught around the keyboard I don't use, but anyway. Got the microphone again. And it's dangled. Okay. There. Job done. Okay, so I'm doing a room probably for no good reason whatsoever because I don't have a Eureka thing here. And I thought I wouldn't do another room until you know I solved the big question. Um, but I was thinking about some stuff, thinking about quarks, and I don't like to contemplate too much of that crap of the standard model. But just trying to think of, obviously, in trying to define the construction of the interior of an electron, I guess it doesn't hurt to pay attention to some of that nonsense. But I was thinking I think there are three major types of quarks, and that sort of fits in with the three dimensions thing. And the dimension thing also, a kind of an obvious fact occurred to me. Probably should have occurred to me a long time ago. But in the three dimensions, no matter which one you make the dimension, there's just three of them always for a material thing, let's say, where you construct this idea of the circle and the 6 points of the circle. So the two dimensions, two of them, fit nicely on top of each other, no matter where I put them. they they just sit right there on top of each other very nicely. But the third one, see, that's the problem. So there's always the odd man out, like the blue sits next to the red nicely, and the blue sits next to the green nicely, and then the red's the odd man out, and then the green and the red, and then the blue is the odd man out, and it's just kind of funny how in the three dimensions there's, no matter how you turn it, somebody turns into the asshole. I mean, so to speak, the one not playing along, not being in the same plane, so to speak. So two dimensions are always in the same plane, and one dimension is outside of that plane. Perforates the plane. So, as a fact, I just think that probably has something to do with the mechanism. And so that's sort of been on my mind. I'm thinking it's like the whatever velocity you have the most of, that'll end up being that, from the matter's point of view, will end up being the odd dimension. And the other two dimensions will be the perpendicular dimensions to that main one. So whatever velocity is the strongest ends up being the. Or maybe it doesn't even have to because of this stuff happening. I mean, I know that looks like something else. I don't mean that to look like anything. But that's, so this kind of diagram is kind of interesting, just in the idea that you can kind of get the picture of it doing this rubbing, and that's where the tangential exchanges are taking place, the perpendicular ones. Because I was thinking about that also, the fact that field energy doesn't interact. So, I mean, you can't make a magnetic field compress a magnetic field, as far as we know. You can only compress where things will line up in the field pressure, but you're not going to undo the fields of electricity or magnetism. As they're calculated, they're always calculated as individual fields that don't mix. So they're only mixed when you put matter in there to mix them, to feel both effects. So the two effects exist independently of each other. And then you have to calculate the effect of the two effects on the matter, but you can't, or the charge, or whatever you're using as a measuring device. But if you were just to measure the fields are unaffected by each other. And that certainly is agreeable with the common experience with light, in that you can't make a photon bang into a photon. And so there's no resistance in the free universe. All these quanta do this. If they do interact, they interact purely kinetic. There's no reflecting, there's no exchanging of polarization, there's no anything. They can't affect each other. They need a piece of matter. They need an element of matter, okay, to be clear, like an electron or a proton or a neutron, uh, to have an effect. So the force can only affect the protons, the neutrons, and the electrons. And through their reacting to the field energy, that creates what we call energy. But the energy was there, it's just that the matter makes it visible, makes its consequence visible. So this also came up in one of the lectures I was listening to, because they were getting on the electrodynamic stuff, like charges. And they always, for their math, they always use this idea of an infinite surface, which is just a way of cheating, because the math gets really complicated if you don't have an infinite surface. Then you're always closer to one end than the other end, and you'll always have a little bit more pressure from the longer end than the shorter end. And so to do their math, and to make it simple, just make it infinite for the purpose of the math. But the real catch to that is so if I have a regular, if you understand the idea of the radiation coming out from as if it comes from the center of gravity, like a light bulb. So it radiates and it has a definite dispersal as through distance. So that's the R squared thing. So if you had straight line vectors coming out, you can understand that as the angle goes out, the square, okay, that area does the 4 times thing in reverse. So the proportion of your impact keeps getting smaller because your single photon is hitting a bigger area of space. So this was another thing I wanted to point out too about gravity, which I thought was sort of interesting, because it's not the way we intuitively think about it. So let's see if I can draw a quick picture of that. All right, so remind me to get back to the charge thing. Yeah, I can't spell. But we knew that. We do know some things. So the trick is, with gravity, the thing that makes it kind of weird, because they talk about it being a weak force, but as it's realized in the world, it's not a weak force, in the sense that there's 2 elements. There's the gravity you cast, and then there's gravity affecting you. And so you have to kind of understand that for, like, say, just an electron sitting here on planet Earth, it's not like one electron causing the gravity. It's the entire field of all of these impacts. So the whole diameter of this sun, or whatever it would be, the entire shadow of that. So everything that is in that square that could be made, okay, with those lines, everything in that cone, or whatever you want to describe it, all that energy is theoretically being blocked. So it's a hugely powerful force when you think about it. And that's why the little electron, if I just put it there with no velocity, it'll fly into the sun quite rapidly. Okay, by the time it gets to the sun, it's going to be moving pretty freaking fast. Maybe the Earth's a better example. It doesn't really matter, but so you can just understand that it's a pretty powerful force, in the sense that the entire sun, okay, now the sun's blocking stuff going this way and this way. There's shadows that aren't going to be hitting this thing. So it's affecting a lot of things, but the point is that it's the shadow of many electrons that is shadowing the one, where the inverse would be minuscule. The amount of shadow this thing is casting on this giant thing is just putridly puny. The amount of stuff that's actually going to go through it to get here, anywhere on this surface, is small. So anyway, it's just food for thought kind of a thing. So anyway, back to the charge thing. So you have this idea of this. So if I had a wire, well, so you understand it. If you have a round thing, it's doing this radiation thing out in all directions, and like a light bulb. And so that's the inverse square, is the idea that all the rays go out and they divergence, and that's what's creating the R squared thing, is that divergence. And so with charge, it gets a little interesting, because if you have a wire, so let's just say this pen's a wire, you have a charge on it, you're going through it. The trick is that it is dimensional. So in one sense, you can say that, okay, there's lines that'll be coming off every element of this thing, and those lines will be radiating like a light bulb. But that's on this surface. It doesn't have much radiating this way or that way, if you can look at it this way. So these dimensions are going to be fairly weak, because you got a lot, there's less going through the depth of the charge, so to speak. Let's see what's the right way to say that. So anyway, I don't think their math is actually entirely correct, because they're almost discounting. So the point would be is that you're still going to get effects from both of these sides. So if you're here, you're getting affected by the straight lines, but the straight lines are coming from all these angles. But there's nothing coming from out here or nothing coming from out here. So that's the point I was trying to make. So the light bulb has this limited range of lines that you could draw from the charge to the surface. And so those lines will they'll do the inverse square thing sort of in reverse. If you thought of the lines coming from the point going to the surface, you could kind of get the idea of how they're diverging. So they'll diverge just by the distance. So instead of the distance squared, it's just the distance. And that will tell you how strong the field charge will be felt from different distances, because essentially you don't have the width thing anymore. You just have this one line. So, and the real trick is that when you use a flat surface and you charge that, and say it was technically very large, at any one point you'd have a charge. But the trick is no matter where you went, it doesn't weaken or stronger. It's the same charge at any location. So there's no weakening of the charge. And at first that doesn't sound right. But it is right, because if you think about it, is in a sense this whole thing gets to be almost like a container that's holding all the force. So the force can't really diverge anywhere, because it's coming from everywhere and it's not going anywhere. It can't escape the box, so to speak, because of this plane. Because you've done both dimensions, you've now eliminated any potential for divergence. And so essentially the force has to stay the same, because none of it escapes. None of it but the tiny percentage that goes out here at the edges. But like I said, if this was a very big surface, an infinite surface, but let's not even say infinite, but just really, really big, the amount spilling off the edges would be so minute by comparison to total charge that it would be irrelevant. And irrelevant to the math anyway, 0.000 something % of the charge. But the point is there's nowhere for the charge to go, so it can't diverge. There's no divergence, because you're always next to something that's producing more radiation. I mean, the lines they just can't escape the box, so to speak. Yeah, so you can't escape them. But I mean, theoretically, you do. The further away you go up, eventually this whole plane would diverge. But like I said, the higher you go up, then that's when you just need to make the plane even bigger. So that's why they use an infinite plane. But I'm just saying, in an infinite plane, you can see that it's almost like a box with sides, and nothing escapes, and therefore the charge can never weaken because it has nowhere to go, so it has to just keep going up, so to speak. Well, anyway, so that's kind of important to all this much. But the funny thing is that they'll be talking about that, and they talk about the force, and again, they just talk about like it's not a real thing, like the force doesn't really exist, like it isn't a real thing, it isn't made out of something. And it's just kind of funny because it's acting just like it was something. I mean, clearly, it's behaving like something in a box. I mean, you just can't miss it. You know, you can't miss that it's behaving just like a light bulb anyway. The fact that they can't even make that connection, you know, when the charge is from a point source, it behaves just like an LED. The charge radiates just like the light from an LED. And then when you make it linear, it's like a row of LEDs. And then when you make it a plane, it's, you know, like a plane of LEDs. And you won't, you know, be able to escape the light. The light will always be intense no matter how far away you get from the plane of LEDs, because the light can't go anywhere. The divergence becomes irrelevant because anything diverging away from you, the source right next to you is diverging right into you. So all the divergences end up doing that constructive interference thing. And for everyone that is going away from you, there's one heading right for you to replace it. So theoretically, if you could make an infinite plane of LEDs, the light wouldn't get any dimmer no matter how far away you went. That's really neat to think about, right? But that's the truth of it. You can't think of how the light could possibly get dimmer if I have an infinitely close sources. Well, very close. They don't have to be infinitely close, but you know what I mean, as close as possible. You know, just really close sources. So it's all full of silicone panels shooting light. That whatever brightness it is at 1 inch, the same exact brightness at 5 inches, the same brightness at 2 feet, the same brightness as 1 billion miles away. That is really quite interesting. That is a piece of stuff to think about. But it also points out how this is a real force. It doesn't go away. See, in that sense, when you do this to it, when you do this infinite plane thing, or even though you can't build an infinite plane, but you can build a preposterously large plane, and then you can understand the point. That example just like I said, it just makes it so easy to see that you have to concede that it's not something different. It's not fundamentally different than light. And yes, they've turned light into a silly amorphous wavy thing, but at least it's a something, not a nothing. And for them not to realize that magnetism and electricity have to be a something, not a nothing. Something moves electrons. Nothing doesn't move electrons. And that is just so... I'm sorry, but it shouldn't have taken 100 years for somebody to say, fuck, that's just obvious, assholes. I mean, come on. How are you missing this? It's moving at the same speed. And, it has these obvious circumstances where if I take away the meaning, the consequences of the divergence by, cramming a huge amount of source into one place, I've gotten rid of the inverse square law. So obviously this is like a fluid rising. This is like a substance moving. It's not a nothing, it's a something. It's moving. It's, it's going somewhere. Just like light goes somewhere. You don't stop it, it goes. And goes and goes and goes. And it's the same damn shit. All right. So all of that has the implication that like this magnet is producing force that gets diluted into the bigger field force. But yeah, it goes forever, theoretically. it blends into the other field energy in the universe, and it's, you couldn't detect it, but it's there. Oh, you always work in pairs, you guys. So anime and shitime. Crappy May, what is it? Video game. Oh, it's that cool video game, Craphead. Oh, damn. So what are you doing, fellas? What's your agenda? V. You have a story, V? I can hear you breathing, so I know you're there. Are you doing something in particular? No? Just.
Oh, hello there!
Oh, that's really interesting. Jeez, you just. Wow. God, you guys are just so cool. Mr. Mandu. Yeah, you're dewy, all right. Yep, like a big piece of dew. Just like dew. You stink. All right. So, sorry. Children on the internet. It should be against the law, really. We should have an adultinet, where we can call each other skanky cunts in peace without a bunch of juveniles showing up to do it. So irritating. It's not so irritating. It's just such confirmation of the basic idea that human beings suck. So anyway, I do have some new drawings, but I just don't know if they're ready for prime time yet. The idea is basically going to be going with something. This idea is kind of the idea for the moment, and these would be the quirks. These would be bars, and so that's what I'm really thinking is that. So anyway, where this has led me to this idea that field energy can't interact and it can only interact with matter, is that matter is something that was formed in some special circumstance, and that it's quanta that are actually stuck together. They're stuck. And uh, and apparently you can rip pieces off of them. I have to come up with some way of doing that, or else you can stick things to them. Let's just say they have a sticky part. Maybe that's what I'll say. They have a sticky part, and the sticky part is you can put pieces on and off the sticky part. So not unlike a DNA molecule, you can just lift a piece out and pop a new piece in, kind of a thing. But you'd have to leave the skeleton the same. You can take the stuff off the outside, but you can't pull the spinal cord off out. But something like that. So that's themes I'm working with in terms of then figuring out how they would slide against each other to do the perpendicular interaction thing. But yeah, no, it's probably way too technical a thing to get into. But I was also thinking that I did think of some software solutions in terms of just using JavaScript and images in an HTML page. I could do some animation, and then I was even thinking I can do it with characters. With the ASCII thing, where you just use characters and proportionally spaced characters, and I could simulate a pretty elaborate movements and have lots of bits. The thing is, I can make something that has 1,000 characters fairly easy, and then I should be able to animate it fairly quickly, theoretically. So it should look pretty realistic you'd actually be able to see something happening. So it's something to work on. But who's got time for this kind of people? Let's see, a transgender man judging people. I don't even know what that means, but I'm not transgender, but whatever. I don't know. What are you still doing here, douchebag? I mean, why are you hanging around, Mr. Mandu? I got to block you on both pages or something? It's just kind of silly. But anyway, I don't even know. Why would somebody who's transgender not be allowed to judge people? I don't understand why. If you have something, I don't know. I mean, you have blonde hair, you shouldn't be allowed to judge people. I mean, what? Why shouldn't any feature eliminate your ability to judge people? Because the judgments are all independent judgments. You're not instantly a hypocrite because you say Nazis suck and you're a German even. There's no hypocrisy there.
I just want to point this out. You look like a transgender on cocaine.
Oh, whatever. And I care?
I just want to
I just I'll point out you look like a guy with a round head.
Okay, I mean heads are like.
Yeah, you're really cool. Oh, Jesus Christ. What did Einstein look like? Right. So this is the other joke of this, right? So these people can't even think enough about this subject to recognize that Einstein was the most unconventionally looking scientist in the history of science. Now, Newton wasn't, I mean, Newton, frankly, put me in some English clothes and, I look like Newton, frankly. We looked a lot alike, except he did his hair a little girlier than me. But, we do have some, I think he had a pretty good forehead. Anyway, so how can you even make rags that are this stupid? I mean, you might as well make them in Chinese or something. There's just no point in speaking English and making sentences that are this retarded. What I look like in the context of physics. I mean, physics doesn't exactly have, it's not the list of physicists and throughout history isn't like, what are they supposed to look like? What's a physicist supposed to look like? Oh, anyway, just so stupid. Well, I mean, I just find it pretty funny. I mean, obviously they're very envious of the fact that I got great hair and I got probably a bigger penis than him, and I mean, I probably like in anything you could measure, like I don't know how much wood is in my blood. I probably have more wood in my blood than him. Yeah. Petty losers. Well, I think it's not so much original thinkers anyway, but I think anybody who thinks probably doesn't spend too much time worrying about what they look like. I mean, it really just isn't something they worry about, So that would be my opinion anyway, is that thinking and spending any time composing a style wouldn't go together. So obviously I don't spend any time composing my personality, structuring my existence to suit anybody. It suits me. And that's it. I mean, I shave because I don't like the feeling of a beard. I don't shave because it pleases the world. But I mean, cutting my hair for no good reason. Oh, that anonymous guy was so cool. Can't wait till he comes back and shoots me again. Dickless, dickless, dickless. This ought to be the international symbol for dickless. It's that stupid anonymous thing. They ought to just put a little tiny penis on the top of the forehead of that anonymous symbol. No penis. All you anonymous types are just a bunch of car keyers and such. Yeah. It's the lamest sack of shit. Untough guys. Sneaky little trolly terrorists. So anyway, so what am I getting at? Yeah, so I might just take a break from this, minutia of figuring out this internal force thing and just do the big picture. You don't get to those arguments because those are probably the more important ones for the sake of getting heard on this subject. But yeah, I just know that if I can get a mechanism that's really solid, that'll be a strong argument point. So I'm sort of horny for it, but yeah, I am killing a lot of time going through an awful lot of geometry. That probably isn't necessary. What I really should do is make sure I got the ins and outs right. What goes in, what comes out, part correct. And so I probably should I should diagram that and just this big picture outside the box kind of stuff. What went into the box, what came out of the box, and then start worrying about those, what's happening inside the box. This clearly matter's different than field energy. I mean, even though I'm saying matter's made of the field energy, it's clearly in a different structure that enables it to interact with the field energy, where it can't in the field. So anyway. So let's see, there was something else I wanted to talk about. Yeah, I don't know. I think that's about it. Geometry and the yeah, the acceleration thing's a little bit interesting. Just because
My bad. It's not cocaine. It's probably weed. Sorry.
Yeah.
Honest mistake.
Whatever. What a jokester. It rubs the lotion on its ass and waits for me to fuck him again. Yeah, come on. Show up again. Let me stick my dick in your ass again. Little gutless coward with a big flabby asshole. Yes, well, again, they're not particles, so the word particle is always going to be tricky. They're made of something, so I guess you could still call something that's made of something a particle, but it does get a little dicey. So I guess you have to use particles for fundamental particles, right? Particles. Ah, there we go. There's a negative comment by Niggity or whatever is niggerette. Just so cool. All right. Well, you're just going to do this type 1 word thingy. I don't really go for that asshole. So fuck you. Emendam's rebuttal of CERN's experimentation is childish. Oh, yeah. It's childish to call a particle accelerator a particle accelerator. Yeah. Yeah, Nigrette. Yeah, well, sorry. You put Nigrette as a name, then you're just asking for it. And you're going to get it. Anyway. Internet really is quite a useless, horrid place. I should go find some other internet. This one sucks. But, real humans don't have time for this kind of stuff. You got to go to work, eat your dinner, watch a couple of TV shows, bone the wife, go to bed. I mean, go back to work. They really don't got time for any of this stuff. So the only people that have time are useless, sexist shit. Sorry, but, like me. Yeah. And, the other people like me who are useless sacks of shit are just obviously shittier than me. Again, he looks like a stoner. Did Einstein look like a stoner? Just asking. Did he? Looked pretty stonier to me. Hmm? I mean, it's like just kind of saying, I'm too stupid to figure out that what somebody looks like really doesn't have anything whatsoever to do with how well their brain works or what kind of arguments they can make or anything. It's completely trivial. And yet you think it's important enough to be the first thing out of your mouth. I mean, that's the most important thing to you, right? It looks like a stoner. It looks like a stoner. And even if I was a stoner, just saying, how would that even be evidence of anything? I mean, as opposed to what? A silent drunk? So what if? So it'd be okay if I drank, a bottle of vodka a day, and I didn't look like a drunk. But if I look like I smoke pot, that means I have no brain. Your logic is really, 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 really bad. Well, your look in combination with your, what is this, vigorously smoking? Yeah, so what? I'm a nicotine addict too. So what? Nobody who was ever smart smokes cigarettes. Oh, okay. I think you got that one backwards too, retard. Yeah, I think all the people with a little bit of character smoke cigarettes. It's all you little pussies who don't smoke who are the idiots. You're the one in the way, fuckhead. Did the other shithead leave? I don't know. Why are you named G Plus account manager? Somebody else asked him. The one with the glasses. I don't know what that means either. I guess he has an authority complex or something, so he wants to seem like he's important. I'm an account manager at Google. Usually Google doesn't let you use the word Google though, right, in accounts. I don't know if you're even allowed to use Google. But I guess that's why you put the little plus after it. Is maybe that confused them, or maybe it's a cross or something. But yeah, I couldn't even. You can't even use Google's name in passwords, because I used to like to password protect my account by the user, by the password Google sucks, and they wouldn't let you use Google sucks as a password. Fuckers. Why are you judging people? Because they need to be judged. That's right. Everything on earth gets judged, asshole. You judge it based on what it smells like, what it talks like, what it looks like, and how dumb the fucking questions are to ask. And when I ask really dumb questions, you say, oh, that's a dumbass. Let's go flush him down the dumbass toilet. Oh, terribly interesting. Not. Anyway, just it really is funny. Life on Earth. Bug planet. That's another one of my theories. That yes, it is a bug planet, and these people are validating that theory every day. So pretty strong theory, also. Humans got big brains full of shit. Yeah, whatever. These people really are dumb. All right, yeah. So just, I guess I have to. I don't know what I'll have to do. I mean, you have to. Maybe I have to. Have to offer a reward or do something. I mean, I already have offered money to people with any number of subscribers to, show up for the debunking, but so where do you show up a lot? What are you doing here? You ask all these questions. What are you doing in this room? I guess you want my dick too, don't you, buddy? Yeah, you want it. But ain't gonna get it. Yeah, I already made that argument to him, but yes. I mean, really, it's a dumb thing. What are you doing here, sucking Eminem dick? Well, I was in line first. Actually, they don't want to suck my dick. They want to suck my ass. So that is a distinction. Why do you say that the 2D simulation of your gravity theory would probably be useless? I think you said that. Well, because the force is going to be created by all three dimensions, right? So, you're talking about what's radiating force. And if you discount the radiation coming from the third dimensional field, which is another polarized field, then you're discounting 1/3 or well, well that's the other thing that's interesting. It has to be kept in mind here is that what's going on is there's likely a lot more interactions with the perpendicular dimensions than say a dimension that has velocity. So as you're gaining velocity, what happens is so when you accelerate, what's clear, okay, I think like this is one of those 85% sure things, is that we know force is emitted perpendicular to that velocity. So as the electron moves, it's obviously, I think, losing, okay, bits of its fatness, its width and the height and width departments. And that happens during acceleration. Now it doesn't happen when something's just moving. So once you've done that, that's it. And then any force you emanate later is what you would emanate later. So the point is that you really do have to account for both of those movements in terms of like something creating gravity, because it's these two dimensions are going to be relevant. You have to count them. It's like the big difference made between Einstein's bent space in 2 dimensions ends up just being something dependent on gravity to make the stuff fall down. So without gravity, the 2-dimensional thing doesn't work. And when you're 3-dimensional, this stupid bent space thing, when you put it in 3 dimensions, the model's preposterous because what it really is the reverse light bulb thing. So you basically have a convergence of force and the Earth is like just being moved as if you're dropping the water out of a drain, and the stuff on the surface will fall into the hole created by the drain, kind of a thing. Except in 3 dimensions, there's no falling in. You're just moving towards the center from all angles. And obviously, that looks like energy. It's pretty hard to sit there and, with a straight face, sit there and say, a vast field of nothing is sucking space in at a tremendous rate. Okay, but there's no energy involved. I mean, that just doesn't make any sense, right? It doesn't make any sense to me. So I'm saying the polarization model might require a model that at least is in some respects respectful of that third dimension. Maybe I can do it without it. I think I can just do it with the two colors and 2 dimensions, but you have to acknowledge the third. And the third is probably the one that's going to be relevant to neutrons. And so that's where I'm going to get into trouble, because there's going to be, I'm going to have to deal with the third dimension in dealing with neutrons. Because neutrons are obviously creating a force that's bonding repulsive protons. So protons that hate each other, neutrons are somehow neutralizing the hate to make them stick together. And yeah, that's obviously got to be explained. And I don't think it's going to be the same force that the protons and the electrons are exchanging that bonds the proton to the neutron. Well, it doesn't bond it. Allows the neutron to neutralize the repulsive forces of the proton. In other words, convert it. So neutrons are like the opposite converter. So where electrons are converting field energy into polarized north and south magnetism, okay, so the electrons are creating the, let's just say, the north magnetism. The protons are creating the south magnetism, and the neutrons are absorbing the south magnetism and emitting field energy. So they're undoing the polarization. Something like that. It's got to be the catch. And so then it's just common gravity that's connecting the proton to the neutron. And right. But well, anyway, I have to think on that one. Because yeah, you still need something to no, you convert the force, then you've overcome it once you've converted it. But I have to think about that. So I guess I probably shouldn't have said probably be useless, but see, when I do it in 2 dimensions, I guess I've just been frustrated. But it just might be because I haven't drawn it quite right. See, the other catch is this stuff isn't really arrows. So this is another thing I wanted to talk about. But I keep drawing it as arrows. But it has, an arrow has dimensions, because what it really is just, it only has mass in the dimension it's moving in. So it really doesn't have the bottom of the arrow is almost totally inappropriate. And so you get this idea of it being, more linear than it is. It's a point, and it goes from one place to another place, but that's hard to draw. It's hard to draw a point going from here to here without starting to make arrows, and the arrows get kind of deceptive. So I have to think of, like I said, if I make a simulation, that might be a lot easier. So if I can just even maybe just spend one day on it and make a really crude simulation, then it'll be easier to manipulate the simulation than it is to do the drawing, because then the timing will be right. So you can't do time in drawings. I mean, it just gets terribly messy, right? I mean, this arrow gets changed. Well, how do you change it without erasing it? And if you erase it, you've lost the history. But maybe I should try color. Well, you can't erase colored pencils all that easy anyway. Yeah, I need something erasable. Maybe chalk. Get a chalkboard. Um, like I say, if you erase it, then you're erasing the history, and you won't remember what things you've already changed. So that might not work either. Well, anyway, it's my problem, I suppose. I mean, it'd be nice if somebody else liked doing this kind of stuff, but apparently nobody else does. So it's me until then. Till somebody shows up and wishes to be a collaborator or whatever. I'm stuck with all the jobs. I have invited people to be collaborators, but no takers. I thought Miles Mathis would be kind of useful, so I did send him an email asking him to take a look at things and see. I think he could do. I just think he's one of these electric universe people, and it's just such a wrong idea. But it's really is like a religion to people. It really is hard to argue with people about physics. It's like arguing religion. Well, I'm just saying there's certain stumbling points I have here. So yeah, some of it would be the math, like some equations they could probably cut through the bullshit and point out how it's quantizable into the system I'm using. I suppose I have already done that to a large extent. Um, so I don't see that as big an issue as it used to be. I mean, it's not. It's really, I love somebody who really can do a good analysis of field equations. Could really be helpful because they could break it down into these elements of and just verify what I'm pretty sure is going on, which is the equation is just taking into account the Brownian motion, so to speak, of the sun and the fact that it's processing on its center of gravity, where Newton's math, the sun was stationary, and that was incorrect. Well, yeah, if you don't mind getting a PhD, and then you could be a PhD physicist to agree with me, that would be really great. But yeah, so the funny thing is, you really don't need a PhD. There is so much information available. Um, I mean, I really have learned uh, quite a lot, in the last couple of years, just in my part time. I mean, it's not like I'm been spending 8 hours a day at this. It's just part time while eating dinner kind of thing, and you really can learn an awful lot. I mean, I came into it with some knowledge. Don't get me wrong. I mean, I did work in a machine shop, and I did have to know. I mean, I've heard a lot of this stuff already in the sense I knew what ohms were, and I knew Ohm's law and all different things because I had to use them, here and there to do circuit boards. Um, so I had some knowledge coming in, but certainly do have to do, well, anyway, it does take time. But there really isn't that much, it's just one observation after another and they all fall together. I mean, the first thing was the idea of a kinetic force, the idea that it could be particles. If you make them kinetic, then you don't have the drag problem. And, then the next big thing was figuring on the polarization idea, that the particles are easily filtered, and you see that with light. And the filter is, it's kind of obviously made out of bars. It's so it kind of gives it away that the shape must have something to do with this kind of, frisbee goes through bars this way, frisbee doesn't go through bars this way. I mean, it's just kind of obvious that that's a mechanism involved here. Let's see. For the false legitimacy the elite seem to require, or at least a master's. Yeah. I don't even know if they require that, because even if there was somebody who was a respected physicist, I still don't think you'd have any traction. You'd still have to force them to have the argument with them. So I'm sure there's some dissenters on like dark matter and dissenters on black holes and dissenters on different things, but they can't get anywhere in physics because there's nobody who wants to have the argument. Physicists are pussies. Nerdy pussies. Yeah, the other part that would be good to have a collaborator for is there's just so many experiments that need to be dissected. And, so it's like, who has time to go through all of them and learn how all of them work to figure out why they're fucking them up? Yeah, the Huygens thing is just so bad. I mean, that's another one where you're just like, I see there was a physicist, right? So the Lewin guy at MIT, in a sarcastic way, right? So this is when at his own lecture. Now he's going to be teaching kids, and he's teaching kids physics. So before the lecture, he actually reads a commentary by another physicist who basically says Huygens is a sham. There's no such evidence of any mini waves. Um, it's you're getting the right answer for the wrong reasons, and that's not what physics should be. So anyway, so it's that kind of commentary, and he reads it, and he basically just walks right over it and says, "Well, if that's what I'm going to do, then I'm going to get the right answer for the wrong reasons," and just ignoring the substance of the commentary, which it's just so bullshit. And yeah, the commentary didn't have in it the big points I would raise is, first explain how you can have an infinite number of something in a confined distance. I mean, I love for physicists to explain how you do that as a principle. How do you do infinite in there? How do you do that? Huge paradoxes. Um, and then the idea that there's absolutely no experimental evidence indicating waves create little waves that create the next wave. There's just no evidence of it anywhere in the history of science. And then there's the third argument, which is, why doesn't the Huygens principle apply in the two-slit experiment? If if single slits produce the Huygens principle, why don't double slits? Why doesn't each one of those slits also Huygens? I mean, obviously the reason is because it would be the four-slit experiment then instead of the two-slit experiment, and that wouldn't work. But I'm just saying, it's just so obviously a contrivance. It's just obvious fudge. It's obvious God of the gaps. We just made it up to fix the math, and fuck you. Uh, how dare you question our authority? I mean, it's just so bad. I mean, physics really should get fined. I mean, they really should fine physics like $1 billion for doing that. Huygens is just not acceptable. That's not acceptable science. To call that piece of shit a principle is just not acceptable. It should be not acceptable to anybody who knows anything about physics and logic. They should say that's just not acceptable. You can't argue for the existence of something as a principle that's just so obviously made up. you know, Principles just can't be. You can make houses out of gingerbread. No, that can't. Bears talk and eat porridge. That just can't be a principle. I mean, it's just and the muting thing again. It's just religion. So anyway, I don't know how long I was muted, but I don't think it was too long. I guess I gotta move this over so I can see when some asshole mutes me. Pathetic creeps. That's the ballless, with ballless men in the world. So anyway, yes, I guess there's just not enough interest, and I probably should just go back to the work instead of just talking about doing the work and such. Yeah, I'm just debating. That's what I'm doing. Because I'm sick of it. So I'm just looking for some way to escape it. Oh, look at that! Somebody's using my name now. Wow, I happened to go to a search of live streams and found you, a person that shares the name of my channel. Yeah, well, you're a liar. Yes, we do know that. Fibber, 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 fibber. Yeah, incredible fibber. Awful, disgusting fibber. Yeah, disgusting, horrible fibber. Mm. Yuck. Lying. I mean, that's another thing people should find offensive. Liars. Despicable. They should be fined billions of dollars. Put them in concentration camps and let them get eaten by cockroaches. I would vote for it. I'm just saying. Can't get enough nicotine out of this piece of shit. Time for a new atomizer, I believe. This one sucks. It has lasted a month. I mean, it's a long time for a $1 device. It wasn't even $1. It was 68 cents. So, yeah, I shouldn't complain. See, that was much better. See, that was, yeah, see, actually got some nicotine out of that one. Don, appreciate it. Yeah, you're so cool, Dawn. It's like a girl's name. He surely has a vagina and no testicles, no doubt. No real Arnold Schwarzenegger type trolls, They all just have no balls. Anyway, so I think I'll say good evening and good night, all that crap, and be on my way. So till the next time and such. And probably should take a day off and get this all figured out and then make a video. Well, I probably should just make videos because these rooms really don't work very well. Yes, I should wait till I have something to something specific, and but we'll see. I do hope to have conversation with somebody who's up to it, but maybe it's enough of this hoping crap. Anyway, thanks, and till the next time and such. Stop the broadcast.